Happy Wednesday. We are, I think, finishing up Unit 9 today. I can't keep anything straight. So yesterday, guys, you solved quadratic linear systems graphically. You just had to graph the parabola, graph the line, see where they cross. Because anytime you solve a system, you're looking for the point or points of intersection. Today, we're solving them algebraically. Little bit more work here, okay? So we're going to get right into it. Don't forget, when we're done, complete the homework, submit it by Sunday, all the fun things.
This is the funnest night ever.
Okay, so let's just briefly review. A quadratic linear system, again, is just a quadratic, a parabola, which is a U, right? And a line that are graphed together. So the solution to any system of equations, whether it's a linear system, a system of inequalities, or a quadratic linear system, is the point x comma y. Or maybe there's multiple points, okay, where they intersect. Yesterday, again, we found these graphically. Today, algebraically, which means no more graph. Keep in mind, solutions to a quadratic linear system, again, are the points where they cross. And yesterday we talked about the fact that if you have a quadratic linear system, you could have two solutions. So for this one here, if we want to identify the solutions, it's just asking us to say, oh, that's the point 2, -3. And this one has two solutions, so it looks like -3, -8 are your solutions. So you could have a parabola and a line that intersect twice and you get 2 points and you need to make sure you write those 2 points somewhere. Or you might see that you have a parabola and a line that cross once and only once. So this would have one solution or 1 point that you need to write. Or yesterday we also saw that you could graph them and they don't cross at all. So here's a parabola and a line that do not intersect. So this has no solutions and you would just write that 0 with a slash through it somewhere on the paper to indicate that there's no solutions.
Easy squeezy lemon peasy.
So for a quadratic linear system, you could get exactly 2 solutions, 2 points where they cross. You could get 1 solution, 1 point where they cross, or no solutions.
Didn't we do this yesterday?
I don't know what you mean.
Same thing can happen when we're solving algebraically. So here's the deal.
So what's the deal with brunch? I mean, if it's a combination of breakfast and lunch, how come there's no leper or no linner?
I'm going to solve this type of system just like I do for a regular system, okay? If it's a linear system, I have you guys follow these same exact steps. Step 1, you're going to solve them both for y. Then you're going to put boxes after equal sign and set those two pieces equal to each other. You're going to solve for x. Now, here's the key. You might have to factor now. After you do this, remember you're looking for the point or points where they cross. So if you get 2 x values, you're going to have to substitute them both in at different times to find the corresponding y values. Or you can just go to your y equals and go to your table, plug them both in, go to your y equals, find the x values you just used, and then find the corresponding y values in the table. Okay, don't forget step 6 here is to write your solutions as points. So let's see what I'm talking about here. All right, here's one I'm telling you off the bat that already has 2 solutions. So it says solve the quadratic linear system algebraically. Notice there's no graph here. Step 1, we're going to solve them both for y. Well, the parabola is done. There it is. The line, we have to get y alone, so I'm going to add 2x. It leaves me with y equals 5 plus 2x. Again, solve them both for y. You don't have to put boxes after the equal sign. I just do that because then I know I'm going to set those 2 boxes equal to each other. In other words, x squared minus 6x plus 5 equals 5 plus 2x. I always like to see if you can factor first. So you guys learn multiple ways to solve equations or quadratic equations. Okay, you learn how to factor, you learned how to complete the square, and you learn the quadratic formula. If you're going to factor, use the quadratic formula, it needs to be set equal to 0. If you're going to complete the square, then you can have your x squared and your x on the left-hand side and the constant, the number with no variable, on after the equal sign on the right-hand side. Up to you. Either way, you should combine like terms. So I see the 2x and the negative 6x. I'm going to subtract this 2x over because I'm going to probably set it equal to 0, but let's see. Okay, x squared Negative 6x minus 2x is negative 8x plus 5 equals 5. It still doesn't equal 0. I need to combine those 5s. So I'm going to move this 5. It's positive. I'll subtract it. What's 5 minus 5? Well, it's 0. So let's see what we're left with. We're left with x squared minus 8x. 5 minus 5 is 0 equals 0. We can factor this. If you don't like to factor, if you like the quadratic formula, you can use that. A would equal 1. B would equal negative 8. C would equal 0 because there is no C. I look at this. Notice there's two terms. No matter what, your first step of factoring is look for a GCF. You have one. For this one, your GCF, they both have an x, so I'm going to take that out. I'm left with x. If I divide it out, and then I'm left with x minus 8 equals 0. We're solving, so don't forget to split and solve. Here on the outside, I'm left with x equals 0. That is a solution. And x equals 8. That's also a solution. Now, unfortunately, you're not done. You have to go back and look at what they asked us to do. We're solving the system. We need the point, which is x comma y. So I know my one point is 0 something, and my other point is 8 something. Again, to find the y values, you have two options. Option 1, which is the longer way, you can substitute them each in individually. In other words, I always go back to the line because it's way easier, it's smaller. So let's look at y equals 5 plus 2x. And first, let's substitute in that x equals 0. So now if I substitute in that x equals 0, I get y equals 5 plus 2 times 0. So 2 times 0 is 0, and 5 plus 0 is 5. So I get when x is 0, y is 5. So that's the point 0, 5. Now I'm going to do the exact same thing, but this time I'm going to substitute in that x equals 8 because that was our other answer. So using the same equation, I'm going to do y equals 5 plus 2 times 8. Simplify it. I get y equals 5 plus 2 times 8 is 16. So 5 plus 16 is 21. So that's the point 8, 21. And now I'm done because I have the points where they cross. If you didn't want to substitute in after you find the x values, you can go into your y equals, plug in. You actually only need to plug in one of the equations. If you want to plug them in both, that's fine. It'll help you check. So x squared minus 6x plus 5. Underneath it, I'm going to plug in 5 plus 2x. I'm going to go to, helps if I type it right in mine. So hold on, sorry. I'm going to go to my table and check where x is 0, y is 5. And I know I did it right because see how the two 5s match. And I'm going to go where x is 8 and where
x is 8. My y values
are both 21. So I also know I did it right because the columns match. So that's the point, 8, 21. Okay, so this again was one with two solutions. When you have two solutions, you're going to get two x values. You have to find the corresponding y values for both of them. Let's look at another case. This one is already telling us it has one solution. Now, if you guys were taking the Regents, it wouldn't tell you. You'd have to figure it out as you go. I'm kind of giving that to you because, there's a lot going on in life. So let's look at this one. To solve the quadratic linear system algebraically, again, step 1, you're going to solve both equations for y. Well, the parabola is already done for you. It says y equals. The line, I have to get y alone, so I'm going to add 2x. That leaves me a y equals negative 2 plus 2x. Again, I'm going to take whatever is after my equal sign and set those pieces equal to each other. So x squared minus 2x plus 2 equals negative 2 plus 2x. Again, I'm going to combine like terms, and I move everything towards the x squared to keep that x squared positive, and I'm going to set it equal to 0. I'm either going to factor it or I'll use the quadratic formula, I think, in a case like this. So the 2x, I'm going to subtract this 2x here, bring it to its like term, which is that one. Rewrite it. I get x squared, negative 2x minus 2x is negative 4x plus 2 equals negative 2. Now I'm going to, again, I want it to say equals 0, so I'm going to move the negative 2. It's negative, so I add it. That's going to leave me with x squared minus 4x plus 4 equals 0. I'm going to see if this can be factored. So step 1, is there a GCF? No. Step 2, I've trinomial, 3 terms. I'm going to do the 4 lines. Bring down my x squared, bring down my positive 4. I'm going to do my signs. So this first sign is a negative, which means this is going to match. The second sign is a positive, so that means that if they have to be the same. So if this is a negative times a negative is positive. I'm going to multiply the x squared and the 4, so I get 4x squared. Well, what multiplies to 4 is 1x and 4x and 2x and 2x, and you're going to pick the 2 and the 2 because it can add to the middle number. So 2x and 2x. GCF of the first two terms is x. You take that out, you're left with x minus 2. GCF of the second two terms, that's a negative 2. So that's a negative 2. I'm going to take it out. I'm left with x minus 2 equals 0. That leaves me with x minus 2 times x minus 2 equals 0. Last step here is to split and solve. And when you split and solve, you should get x equals 2 for both of them. Well, if that happens, that means that you just have one solution. Yes, you solved it and got 2 twice, but it's the same number. So my solution is going to be 2 comma something. And I know these are long and you feel like, oh, I did all this work and found x, but you can't forget you're looking for the point or points where they cross. So now I have to go through, and after all of that work, I still need to find y. Again, you could just take the line, which is y equals negative 2 plus 2x, and substitute in that x is 2. So I get y equals negative 2 plus 2. And again, we found x to be 2, so 2 times 2. Simplify that. We get y equals negative 2 plus 4, and negative 2 plus 4 is 2. So they cross at the point 2, 2. And there's your solution. Okay, so when you solve this, again, your solution here has to be the point where they cross, and they happen to cross once at the point 2, 2. I would take a second and just in my calculator in the app, quickly graph it. So x squared minus 2x plus 2. Underneath it, the line was negative 2 plus 2x. I'm going to go to my table first and check the point 2, 2. Well, look, at 2, the y's match, 2, 2 across. I could also hit the graph key if I wanted to. And if you were taking the regions on this, you would want to do something like this, and you'd see they cross once. And there they are, the point 2, 2. So it's really not hard. This is actually nothing new. You've solved systems before. You've factored before and solved quadratics before. So same idea. This one, they're telling me there's no solution. So let's look at this one. Again, step 1 to a system, we solve them both for y. Well, lucky for us, this one's solved for y, and this one is solved for y. So what I'm going to do now is set those two pieces equal to each other. X squared minus 2x plus 3 equals negative 2x plus 1. And again, I'm going to set it equal to 0 and either factor or use a quadratic formula. So to combine like terms, I'm going to add this 2x over, and I always move towards the x squared. Leave your x squared positive and just trust me on that. If you make your x squared negative, you will have to factor out a negative 1 first, like as a GCF of negative 1. It just causes more problems. Leave your x squared positive for the rest of your math career. Okay, here we go. So I'm left with x squared. Well, negative 2x plus 2x cancels, so x squared plus 3 equals 1. Now, I could, if I look at this one, I actually don't think I'm going to factor this one. If I wanted to solve for x, couldn't I just subtract this 3 over here, right? Because now I have x squared equals a number. Well, x squared equals 1 minus 3 is negative 2. And how would we get x alone? We'd square root it. Well, what's the problem here? What's the square root of a negative? Try it in your calculator. What's it going to tell you? It's going to say, oh, there's an error. You can't square root a negative, which means that you did it completely correct. It just means there are no solutions, and you're done. Okay? If there's no x's that work, you don't have to substitute in anything to find y. So this made the problem nice and easy. Oh, my stomach's growling. I think I'm hungry. All right, let's look at this one. So here, and I love the little camel on the side here. Same idea like we did yesterday. We just threw in some function notation. Remember, f of x and g of x are the same thing as y. So if you want to rewrite these as y equals 3 over 4x squared and y equals 48, you're good. We're still solving the system. So they're both solved for y. I'm going to take these pieces and set them equal to each other. In other words, 3 over 4x squared equals 48. Well, for this one, again, notice I only have an x squared. If you only have an x squared, then you can do the same steps we did in the last one. You can just get x squared alone and take the square root. Well, how would you get x squared alone? Couldn't you just, in one step, divide by 3/4 or 0.75? Just remember in your calculator to do 48 either divided by 0.75, because that's the same thing as 3/4, or 48 divided by parentheses 3/4, and I get 64. Now to get x alone, I'm going to square root. Does this one have an answer? It does. What is it? A lot of you are going to say, it's 8. And you're halfway right, because if you square root something, if it has an answer, it should have 2 of them. The square root of 64 is positive and negative 8. So that means when you're solving this system, this has 2 solutions. One where the x value is positive 8, one where the x value is negative 8. Oops, not 0. I don't know why I wrote that. Okay, so now we have to find the y values. You are more than welcome to just use your calculator to find y. Okay, for me, I'm going to substitute in really quick. And I'm going to have to do it around the camel's head. Now, the line here is y equals 48. Nothing to substitute into. What does that mean, y always equals 48? If that confuses you, because I think at your age or even older, that would have confused me, just being honest. I'm going to take the parabola this time. So to find y, I'm going to take that y equals 3/4 times x squared, and I'm going to substitute in 8. So y equals 3/4 times 8 squared. Put that in your calculator in one step. 3/4 times 8 squared, and you get y equals 48, like I just said. Kind of weird, right? Do the same thing for negative 8. So y equals 3/4 times negative 8 squared, and you get y equals 48. Or you could have used your calculator and plugged those guys in, but either way, you need that your solutions are the points 848 and negative 848. And again, I would take that quick second and just say, you know what? Let me just plug this in my calculator, each one. So 3/4 x squared, and then y equals 48. And I could hit the graph key. It's going to be a hard one to see, or I can go in my calculator and scroll at negative 8. I know I did it right because my y values both match. Okay, they're both 48. And I could scroll to where I have x is positive 8. And I get my x value, or my y values match as well. They're both 48. So again, I know I did it right. Woohoo! We're like rock stars here. Okay, so keep in mind a quadratic linear system, it can be solved algebraically using the substitution method. And you can always check in your calculator. For a quadratic linear system, you will always get either 2, 1, or no solutions. And you need to indicate that. So you need to see the actual points where they cross, okay? Complete all of this homework, which is it Unit 9, Homework 11? I have no idea.
I can't do this anymore, man. My head's about to explode.
Whatever, this homework is attached to it, if that's the correct number or not. If you have questions, guys, join the Google Meets. We probably only have a couple weeks of them left. Just be great to see you at this point. Yeah, everything's due by Sunday at 11:59. Have a good one.